Hello and good morning everyone. My name is Ahmed Imad and I'm from group number 1. First, let me begin by introducing my group members, which are Ikmal Hanafi, Wong Li Hong, Muhammad Firdaus, and Nazaruddin. Now, let me give some introduction about our project. So our project is about relay coordination, which is a tripping of protecting the relay in sequence or order in an electric power system. It is required to isolate the faulty part with minimal relay and circuit breaker operation. Relay coordination study and analysis is performed to ensure the safety operation of a system functioning correctly to avoid any noxious tripping, as protection is a major concern in any industry and the relay on protective devices. The reason for noxious tripping is modification of protective devices and their settings at the time of maintenance without performing suitable study and analysis. The aim of the coordination study is to determine the characteristics, ratings, and settings of overcurrent protective devices, which will ensure the minimum unfaulty load is interrupted when protective devices isolate a fault or overload anywhere in the system. So, during relay coordination study and analysis, a set of tests should be carried out. First, load flow test, short circuit analysis, and device time current characteristics. In our assignment, we were required to use ETAP software to produce a one-line diagram of a power system network with all parameters already given. We were given 6 objectives to meet. First, run a load flow test to determine the maximum current at each feeder, run a short circuit analysis to determine fault current at all buses, select transformation ratios of CTs utilizing class 5B CT and suitable accuracy limit current, determine the values of pickup, setting, and time dialing settings of all relays to ensure a coordinated protection system. Next, produce time current coordination curve of relays on the system. And lastly, confirm the sequence of relay operation for three-phase short at each bus. The goal of this assignment is to analyze the following circuit and determine protective device coordination to achieve optimum equipment protection and selectivity. Now, I will let my group members to proceed.
Hello, I am Firdaus from Group 1. I will be doing the solution for question 1. First, we design the network and we put the value as in the network data for Group 1 in the column 1. And then, we will run the load flow analysis to determine the maximum current at each feeder. First, click this button and run the load flow analysis. Load flow analysis is necessary for making sure that each component runs at optimum operating point. So as you can see here, for relay 1, the max load current is 61.9 ampere. Same goes to relay 2. Both relay 3 and 4 also have the same current, which is 743.3 ampere. The current values for each relay were tabulated in this table.
Assalamualaikum and hi, my name is Nazaruddin Iswan, and for my part is to perform the short circuit analysis to find out the fault current at each relay. So what we're going to do first is to click on the star protection and coordination, and then next we're going to click on the fault insertion, and for the first case we're going to click on bus 1 since we're going to fault bus 1. So we're going to wait until it has finished loading. So after it has finished loading, we're going to click on the sequence viewer. So this sequence viewer is going to show all the fault current that is occurring at each relay in our circuit. So our circuit has 13 relays, so it's going to show from relay 1 until relay 13. So here, as you can see, at relay 13 our fault current is 0.486 kilo ampere. At relay 10 it is 0.3 to 7 kilo ampere. Relay 12 is 2.074 kilo ampere, and so on until relay 1. So next we're going to tabulate all this data, the data of the maximum fault current into a table for faulted bus 1, and we're going to reset the fault. So after the fault has been reset, we're going to click it again, and for this case we're going to fault bus 2. So basically we are just repeating the same step until bus 5. So view the sequence viewer, then tabulate all the data of the fault current at each relay and continue on to the next bus. So I have done the tabulation of data. So this is the tabulation of data that I have done. So this is for faulted bus 1, faulted bus 2, faulted bus 3, faulted bus 4, and faulted bus 5. So here is all the relay fault current that is occurring during their respective bus fault. So here what we're going to do next is to obtain the maximum fault current that is to occur on each relay. So for example in relay 1, the maximum fault current that has occurred during faulted bus 2 is 0.404. So we're going to take that value as our maximum fault current for relay 1. So for relay 2 it's going to be 0.404, and there is our maximum fault current for that relay. And for example, as you can see in relay 10. So in relay 10, the maximum one is 0.393, that is during the faulted bus 4. So that is our value for maximum faulted current for relay 10. So after obtaining all this maximum fault current at each relay, and then we can continue on to the next step.
So for part C, we are going to find the city ratios for each relay and also the class for each relay. So to find the city ratio and the class, the formula that we are going to use is ALF equal to maximum fault current divided by the city ratio, and also for ALC, accuracy limit current, equals to ALF times with the rated current. The rated current is 1 ampere that we decide to choose rather than 5 ampere. So we choose 1 ampere for rated current because it saves more cost compared to 5 ampere. And for relay 1 and relay 2, the maximum load current is the same, 61.9 kilo amp. And when fault is present at bus 1, the fault current at relay 1 and 2 is 0.404 kilo amp. So the city ratio that we will find must be larger than the maximum load current. So in this case, we choose 100/1. So the maximum fault current divided by city ratio, we got 4, and the nearest value to it is 5. So our class is 5P5. And the same goes for relay 3 and 5. The maximum load current is 743 kilo amp. So the city ratio must be larger. We use 800/1, and then the maximum fault current is 4.842 for relay 3 and 4. And we divide it, we got LF equal to 6. So the nearest is 10. So our class is 5P10. And for relay 5, our city ratio is 400 from 100 kilo amp. So the city ratio is much more larger than the maximum load current, because if we use smaller than 400, our ALF we will got more than 20, which is not the result that we want, because it will cause distorted in the relay, also for the protection system. So that's why we increase the city ratio to 400. So we got 17, and we can do 5P20. So for relay 6, our city ratio is 900, our class is 5P15. Relay 8, relay 7 and 9, and this is all the same flow, the same work that we use, and this is the result that I already tabulated. So for each relay, relay 1 until relay 13, this is the city ratio, and this is the class. So after we got the result for city ratio and class, we can put it into the ETAP. So from the network system, we can select, double click the relay, and we can click at rating And from rating, we can put our calculated seat ratio into this section, ratio section. So as you can see, I already put it 100/1, and our class is 5v5, our burden is 25v. So we do the same thing to all relays until relay 13. So for relay 2, it's the same as relay 1, 101 ratio, 5v5 class. Relay 3 and relay 4, same, 800/1, 5v10 class. Relay 4, 801, 5v10 class. Relay 5, 400, 5v10, 5v20 class. And relay, the bottom relay 10 until relay 13, 100, 5v5, 900, 5v5, 600, 5v5, and 150/1, and class 5v5. So that's all for me. Thank you.
Hello, I am Firdaus. So for now, I will do for part D. We need to determine the values of pickup setting and time dial setting. So this is the formula for plug setting, max load current over CT ratio times 100%, and RSI for PSM, RCOT, and ROT, and then we have discrimination time is constant, which is 0.4, and to find the TSM is we need to divide ROT divided by RCOT, and then after we get TSM, we can get back ROT equal to TSM times RCOT. Okay, so this one is for relay 13. For relay 13, it starts from here, so we don't have any fault downstream, so we just calculate the PS 61.9%, and we get 75, and then we can get RSI, the PSM, and RCOT, and we can straight away get ROT. And then for relay 9, you see the fault downstream, relay 12. This part here, we have relay 9, and we have relay 12 and 13, so we take the largest ROT, which is relay 12 here, 0.4824 compared to 0.4161, and then from that ROT we plus with discrimination time, and then we can get our TSM, and then for the relay 9 fault downstream of relay 6, we can get our ROT. And after that, we tabulate the data. We have our pickup setting and we have TSM, and from there we can insert the value here. Let's say for the relay 4, so relay 4 here is 0.929, so we double click and go to OCR, we insert the value 0.929, and then the TSM is 0.583. Click OK and save.
Assalamualaikum, and for part E, to produce a time current coordination curve of the relay of the system, firstly what we need to do is to open the star protection and coordination. And then next we're going to click on the relay that we're going to produce the graph on. So I'm going to choose relay 1, 2, 3, 4, and 5 by holding control. And then here you're going to click this create star view, but I've clicked it and save the simulation here so we can view it. So here, as you can see in this graph, so relay 5 will operate first, followed by relay 3 and relay 4, and then relay 2 and relay 1. So that's for relay 1 until relay 5. So next, we're going to simulate on relay 6, 7, 8, and 9. So for that, I'm going to click here again since I simulated it. So this is it, 6, 7, 8, and 9. So I'm going to click again, and then here we have the graph for the relay 6 until relay 9. And then we're going to proceed on to the last relay, which is relay 10, 11, 12, and 13. So I'm gonna do the same thing. So here is the save one. So here, as you can see, if there is fault happening, so the one that we're gonna treat first is gonna be relay 10, followed by relay 13. And there is some overlap here because relay 10 and relay 13 is in parallel with each other, but still it has good discrimination because it is discriminated from relay 12 and relay 11. The same goes for relay 12 and relay 11, in which they look like almost overlap because they are parallel with each other. So that's all.
Hi, I'm Liho, and I will discuss about the sequence of relay operation of the relays for three-phase when it's shut at each passes. This is the example that I have screenshot for the fault when occurs at the bus 5. And here is the data, and we just compare the data when the config is a normal phase. Then here is the data that I have collected when I shut, and can be said the fault occur at each buses. For the bus 1, when it occurs the fault at bus 1, the relay 13, the relay 10 will be operated first, then followed by the relay 13, then followed by the relay 12, and relay 11, then followed by the others. Then when the fault occur in the bus 2, the relay 10 will be the first relay to operate, and followed by the relay 13, and followed by the relay 12 and 11. And when fault occurs in the bus 5, the relay 10 still will be the first to operate, and followed by the relay 13 and 12 and 11 and the others. And when the fault occurs at the bus 4, the first relay will be operated is the relay 13, then followed by the relay 8, and followed by the relay 10 and 12 and 11 and the others. When fault occurs at the bus 5, the first relay to operate is the relay 9, and followed by the relay 10, and followed by the relay 19, 13, and others. Then, in order to confirm the sequence, we need to make sure that the max current will obtain after each passes is shuttered. The max current of relay 1, 2, 3, 4, and 5 is obtained from the bus 2 and 3. It means that we need to compare the ROT, which is the relay real operating time we calculated, to the ROT when the bus 2 and 3 is shut for the relay 1, 2, 3, 4, 5. And after we compare, it can be almost similar to bus 5 relay. And for the relay 6, 8, 10, and 11, is obtained, the max current from this relay is obtained when the bus 4 is shuttered. So we need to compare this relay 6, 8, 10, and 11 ROT to the when the bus 4 is shuttered. Then we can see that it's 871, 473, 507, and 597. And for the relay 7, 9, 12, and 13, we need to shut the bus 5 and compare the ROT with the ROT of relay 7, 9, 12, and 13 with the ROT that we have calculated. Then we can see that the result is almost similar, and we can conclude that the sequence of relay operation of the relays for three-phase is confirmed. Then now proceed to the conclusion. We have learned on how to use and understand the ETAP software from this assignment. From this assignment, the result of log flow and circuit analysis, the selection of transformation ratio of the CTs with its requirements, PU setting and time deal with justification, time current coordination curve, and the correct sequence of relay operation of the relays for three-phase shut at each passes was shared. Besides, we also have a deeper understanding of the function of the relay on how it operates and the way it chooses on which protection relay to be used first. Furthermore, we have better understanding about the overcurrent protection, and it is essential knowledge to know for the electrical system work, as it can save or prevent a major catastrophe such as a generator blow and an entire neighborhood blow out. Thus, we can deduce These skills will be useful for us if we are involved in electrical engineering. That's all from. Thank you.